Hi there. Let's work out this question, example 1 from our lesson, in which we're being asked to find the concentration of our sample, which in this case is our acid, and we need to use the steps from a titration using molar concentration as well as just basic stoichiometry to solve this question. So let's go ahead and do it. Sometimes when you're approaching these questions, if you're a visual person, it's helpful to actually draw yourself a little drawing of the titration and label what you know. Other people might just like to set it up kind of for themselves clearly. So let me do it in two different ways. One way is just to kind of consider your sample and your standards separately. So the sample here is just the unknown concentration that we don't know. And what is our sample? Well, our sample in this case is H3PO4 phosphoric acid. Okay, so it would be helpful here to determine what it is that we have for our sample. So for example, if we read it, we have a 19.8 ml sample. So we know our volume. The volume of sample here is 19.8 mils. Okay, and it has an unknown molarity, so we don't know what its concentration is. It's going to be titrated, and we're trying to find the concentration of that sample. So what we're trying to find here is C. So right now we don't know C. Okay, let's put our standard over here. So just by organizing the information for yourself in any way that makes sense to you, it's going to be easier to carry out these calculations. Our standard in this case is the solution that we're using to titrate. So it's the potassium hydroxide, the KOH. And what do we know about it? We know its volume is 25 mils. Great. Okay, we also know its concentration. The concentration is 0.500 molar, or moles per liter. Okay, so from this we can find the moles of KOH. So this is the first step. Some people might like to do the exact same idea, but maybe drawing themselves a little picture. I know sometimes students like to just actually draw what a titration looks like. So they might draw their flask here. This isn't a very good flask, but you can see here that you could label your sample. Again, anything that works for you. Okay, so the H3, the phosphoric acid is our sample. And again, you could put that exact same information down there. You could write your volume, which is 19.8 mils. And then here's your standard here in the burette, which is the potassium hydroxide. And then you could write all the same information. You could write the volume and the concentration. So however it makes sense to organize it for yourself, go ahead and do that. Okay? I'm going to use the way I've set it up first here, just for simplicity. And let's go ahead now and figure out how are we going to get to the concentration of our sample. Recall that in order to figure out concentration, we need to know moles. We have the volume, but we don't have the moles. So we're going to use that C is equal to moles over volume, which can also be written in the handy triangle. Right, C on the bottom, N over V. So once we know the moles of our sample, then we could find out the concentration. But to get there, we have to start over here with our standard. So we've added a certain amount of our standard, and we know the concentration, we know the volume, so we can find the moles of this standard. Then we can cross the mole bridge from standard over to our sample and find the moles of our sample. Then we can finally calculate our concentration. So it's a three-step process. So we're going to start with our first step, which is going to be to find the moles of standard. So to find our moles of standard, we're going to use this formula for concentration that relates moles and concentration and volume together. And there's a couple things we need to remember. One is that we're solving for moles, which is in the top of our triangle. So if we cover up that N with our finger, we see that moles are equal to concentration times volume. Equally, you could rearrange this formula over here and you can multiply both sides by volume. Okay, so that it cancels on the right, and we have moles are equal to concentration times the volume. And we also need to be careful that our volume is in liters. So the volume that we have here, 25 mils, we need to report that in liters to use it in our calculation. So you can convert this, or we can divide it by 1,000, move the decimal place over 1, 2, 3 spaces to the left, so that we have 0.0250 liters. We want to keep all our sig figs there. So now we have all the information we need. We can solve for moles. So the moles of KOH are going to be equal to the concentration, which is 0.508 moles per liter, multiplied by 0.0250 liters, and that is going to come out to be sorry, I just realized I have an error here in my concentration. Sorry, 0.500, not 0.508. That's just a sloppy zero. Okay, so our answer is going to come out here to be 0.0125 moles of potassium hydroxide. So there's our moles of standard. And so we might want to go back up here and fill that right in for ourselves. 0.0125 moles. All right, great. Now we know how much standard we added in moles, and we can now cross the mole bridge in our reaction equation using the mole ratios of the standard in the sample. So we're concerned about the mole ratio between KOH, our standard, and the phosphoric acid, our sample. And that's our next step. So step 2 is to cross the mole bridge and find the moles of sample. So to find the moles of our sample, which are over here, the phosphoric acid, we need to use the mole ratios. And we see that we have a 1:2 ratio. We're looking at the coefficients in front. There's a little invisible 1 here. So a 1:2 ratio between our moles of phosphoric acid and our moles of potassium hydroxide. So for every 1 mole of phosphoric acid, 2 moles of potassium hydroxide are going to be required. So this is a 1:2 ratio, and that's important because we're now going to use that in our calculation. So we want to find the moles, of H3PO4. And we're going to start with the moles that we've determined in our last step of our standard that we added. So we determined that we had 0.0125 moles of potassium hydroxide. That's how much standard we added in the titration. Okay, and now we're going to use our mole ratio here. And I'm going to be careful to make sure I put my moles of potassium hydroxide on the bottom of my calculation in the denominator of my conversion factor, because I want to cancel out of moles of potassium hydroxide, and I want to get into moles of phosphoric acid, which is my sample. Okay. Essentially, just when we look at it in the reaction, half as many moles of phosphoric acid are required for every mole of potassium hydroxide, or basically there's twice as much potassium hydroxide that's required for this balanced chemical reaction. So we know how many moles of potassium hydroxide we added, so the moles of phosphoric acid are just half of that. Okay, but we can do it as a calculation here, okay, to make sense of it. And we're going to cancel out of our moles of potassium hydroxide. So we're dividing this number by 2, and our answer is going to come out to be equal to 0.00625 moles. And now we are talking about moles of phosphoric acid, or our sample, H3PO4. And we're almost ready for the last step, which is now just to convert from moles into an actual concentration using the volume of our sample. So we'll come back to my original question here and we'll fill this in. So we've now found the moles of our sample, which was 0.00625 moles. And we're going to use this, clean this up a little bit. we're going to use this this equation for concentration now to determine the actual concentration of our sample. We have to be careful that we use the correct volume. It's always the volume of the sample when you're calculating the concentration of the sample. So if you haven't sort of mapped out your information the way I've done it here, and you're just using your original question, just be careful when you go back to it that you're using the correct volume. So the 19.8 mils of sample, that's the volume we want. We don't want to accidentally use 25 mils again. We also don't want to add these together, okay? Because we're concerned about the original volume of our sample, because this is how many moles were originally present in our sample. Okay, so let's go ahead and carry out this final concentration. Just going to give myself a little bit of space here. So we have the formula: concentration is equal to moles over volume. And we have all of that information now. So our moles are 0.00625. And we need to be careful putting in our volume. It always needs to be in liters. So we do need to convert this volume in milliliters to liters. If I move the decimal place over 1, 2, 3 spaces to the left, I have 0.0198 mils. Okay, 0.0198 liters, not milliliters. Okay, and my last step now is to go ahead and make that calculation to divide the numerator by the denominator, and it comes out to be equal to 0.316 moles per liter, which can of course also be written as 0.316 molar, or capital M, moles per liter. Okay, and that is our concentration, which is the concentration of our sample, H3PO4, the phosphoric acid. And there we go. Checking our sig figs before we finish. We have 3 sig figs reported here. We've been carrying our sig figs through our calculation, but if we come back to our data and just look at all the information we used, we had 3 sig figs in our volume of our sample, 3 sig figs in the volume of our standard, 3 sig figs in the concentration of our standard. So we should have 3 sig figs as well in our answer, which we do, and so we're ready to go ahead and report that as a final answer. And we're all done.